Welcome back to G Fun Facts Online. Today we are going to take a journey that is both terrifying and beautiful. We are going to look into a mirror, but this mirror is floating in the dark of the cosmos, 650 light-years away. It is a ghost. It is a premonition. And thanks to data released in late January 2026 from the James Webb Space Telescope, or JWST, our understanding of this object, and our understanding of our own future, has just changed forever. We are talking about the death of stars. Specifically, we are going to break down the monumental new data on the Helix Nebula, the Ring Nebula, and the violent Wolf-Rayet 124. This isn't just about looking at pretty pictures. This is a forensic crime scene investigation on a galactic scale. So let's settle in and open the file on what astronomers are calling the Eye of God. For 2 centuries, the Helix Nebula has stared back at us from the constellation Aquarius. If you look at the old Hubble Space Telescope images, it looks like a giant, serene eye. It has this soft, turquoise and rose-colored eyelid of gas. It looks peaceful, but the James Webb Space Telescope has stripped away that serenity. Webb's near-infrared camera and mid-infrared instrument pierced through the dust that was scattering the visible light. And what they found underneath is shocking. It is not a smooth ring. It is being described as a violent, churning, cosmic lava lamp. The most striking features in this new 2026 dataset are these things called cometary knots. Imagine clumps of molecular gas, each one of them as large as our entire solar system. In the high-resolution data, they look like tadpoles swimming upstream against a river of ultraviolet radiation. There are tens of thousands of them. These are the survivors. They are clumps of material that were dense enough to resist being instantly vaporized by the dying star at the center. But here's the part that defies our previous models. Webb identified what are being called shielded zones. These are dark pockets sitting in the shadows, cast by those massive cometary knots. Inside these shadows, the temperature drops just enough to allow for a miracle of astrochemistry. Despite the intense radiation that should be ripping molecules apart, these zones are acting as factories. Webb spectrometers detected the unmistakable signatures of polycyclic aromatic hydrocarbons, or PAHs. These are complex, carbon-based organic molecules. They are considered the building blocks of prebiotic life. Think about the irony of that for a second. In the immediate blast zone of a dying star, in the middle of this nuclear catastrophe, the ingredients for new life are being synthesized in the shadows. The new images essentially serve as a thermal map of stellar death. At the center, you have deep blue colors representing gas heated to over 100,000 degrees Kelvin, glowing with the energy of 1,000 suns. Moving outward, you see golden yellows, where atomic hydrogen cools down enough to bond into molecular hydrogen. And at the fringes, russet reds show the cold, dusty material that will eventually drift off into the Milky Way to form new stars and planets. But to really understand what Webb is seeing, we have to understand the engine that drives this. We need to do a very quick crash course in Stellar Evolution 101. A star is essentially a delicate war between gravity crushing inward and nuclear fusion pushing outward. For billions of years, a star like our Sun wins this war. But gravity is patient. Gravity always wins in the end. When the hydrogen fuel runs out, the core collapses and heats up, while the outer layers puff outward. The star swells into a red giant. If you were standing on Earth during this phase of our Sun's future, the horizon would be swallowed by a wall of angry red fire. Mercury and Venus would be gone. Earth would be scorched to a cinder. Then comes the thermal pulse. Deep inside, the star tries to fuse helium into carbon, but it is unstable. The star starts to spasm. It undergoes these violent pulses that literally blow its outer layers off into space. Imagine a snake shedding its skin, but the skin is made of plasma, and the shedding happens in violent, rhythmic bursts over thousands of years. This is the star taking its final breath. It is coughing up its own lungs. Once those layers are gone, all that is left is the naked core, a white dwarf. It is a diamond-dense ball of carbon and oxygen, about the size of Earth, but with half the mass of the Sun. When the invisible ultraviolet light from that white dwarf hits the expanding gas clouds, they fluoresce. They light up like a neon sign. That is a planetary nebula. It is a brief tombstone, lasting only 10 to 20,000 years before fading away. Now, while the Helix Nebula looks like an eye, the famous Ring Nebula in Lyra has always looked like, well, a ring, a perfect donut. But Webb has completely shattered that illusion too. Based on 3D modeling from the new data, we now know the Ring Nebula is actually a distorted torus, shaped more like a jelly-filled donut or an American football. We are just looking down the barrel of it. Webb revealed that the center isn't empty. It is filled with hot gas and curious spikes, or bicycle spokes of shadow. But the biggest mystery came from a team using the William Herschel telescope in tandem with Webb. In January 2026, they announced the discovery of a massive bar of iron atoms embedded within the nebula. This structure is colossal, extending 1,000 times the distance from the Sun to Pluto. This is a heavy metal mystery. Low-mass stars like the one that created the Ring Nebula should NT be producing iron. That is usually the job of supernovae. The leading theory is that the star didn't make the iron, but concentrated it. The dynamics of the stellar wind, maybe influenced by a hidden binary companion star, might have swept up existing iron from space and trapped it. It challenges everything we know about fluid dynamics in low-gravity environments. Webb also allowed astronomers to count approximately 20,000 distinct globules in the Ring Nebula's halo. Each one is a dense world of molecular hydrogen, the seeds of future star systems. We can essentially see the evaporation tails on them, where the central star is slowly boiling them away. It is a race against time. Will they survive to form new planets, or will they be destroyed by their creator? Now, let's move to a detective story. When JWST released its first images way back in 2022, the Southern Ring Nebula was the sleeper hit. It looked like a shaky pool of water. But hidden in that image was a murder mystery. Hubble only saw one bright star in the center. Webb saw two. The bright star we had watched for years was actually just an innocent bystander. The real culprit, the dying star, was a tiny, red, dust-shrouded point of light sitting right next to it. They are a binary system, orbiting each other in a tight dance. As the dying star puffed out its layers, the companion star acted like a blender, churning up the gas and creating those complex, shaky rings. Recent analysis has even revealed a wobble in the structure, suggesting there might even be a third star involved. It is archaeology written in gas. Webb also revealed a lattice-like exoskeleton of hot molecular hydrogen. It suggests that as the star's shell expands, it cracks and fractures like a drying mudflat, creating these beautiful chaotic geometries. But not all stars die gracefully like the ones we have discussed so far. Some die young, fast, and loud. Enter Wolf-Rayet 124. This is a massive star, 30 times the mass of the Sun, located 15,000 light-years away. It is in a rare phase called the Wolf-Rayet phase. It is burning fuel at a voracious rate, shedding its outer layers in a screaming wind moving at millions of miles per hour. It sheds the mass of the Sun every few years. Webb's image of this star looks like a cherry blossom tree on fire. But this is a ticking bomb. This star is on the brink of going supernova. When it does, it will outshine the entire galaxy. But here is why Wolf-Rayet 124 is so important to science. It solved the dust budget crisis. For years, cosmologists couldn't figure out where all the dust in the early universe came from. Standard theory said supernovae destroyed more dust than they created. But Webb looked at the cold dust around Wolf-Rayet 124 and found immense quantities of it. It turns out these stars are incredibly efficient dust factories. The dust grains formed in their winds are large enough to survive the explosion. This means stars like this are the seeders of the universe. The silicon in your computer chip, the iron in your blood, the carbon in your DNA. It was likely forged in the winds of a star like this billions of years ago. This brings us to one of the most profound realizations from Webb. The space between stars is not empty. It is a chemical broth. Webb has found a zoo of molecules: carbon monoxide, silicon carbide, even fullerenes, which are these soccer ball-shaped carbon molecules called buckyballs. And as we mentioned with the helix, the presence of PAHs in these harsh environments suggests the universe is hardwired to produce organic chemistry. Even in the most hostile places, carbon atoms find a way to link up. The ingredients for life are not rare accidents. They are a standard byproduct of stellar death. So what does this mean for us? What happens when our sun takes its final breath? Using this data, we can construct a timeline of our own demise. Fast forward to the year 5 billion AD. The sun exhausts its hydrogen. It swells into a red giant. Mercury and Venus are swallowed. Earth's oceans boil away. The atmosphere is stripped, and the ground melts into magma. From the surface of Mars, the sun would look like a colossal red wall taking up half the sky. By the year 7 billion AD, the sun becomes unstable. It shudders with thermal pulses. A howling solar wind strips the atmospheres of Jupiter and Saturn. Their rings are blasted away. Then, the ejection happens. The sun sheds its outer layers. A cloud of gas, containing half the sun's mass, expands outward. Then, the core is exposed as a white dwarf. The gas ignites in UV light. If an alien astronomer were looking at our solar system from deep space, they would see a ring of glowing green and red. It would look just like the Ring Nebula. The cometary knots we see in the helix, those would be the vaporized remains of our own Oort cloud and Kuiper belt. The comets that once brought water to Earth would be glowing clumps of gas racing into the dark. Finally, by 10 billion AD, the nebula dissipates. The gas drifts into the Milky Way to become part of a new star, perhaps a new living world. The sun remains as a cooling white dwarf for eternity. It is a somber thought, but there is a philosophical beauty to it. When we look at the Helix Nebula, we are looking at a mirror. The carbon in our bodies was once floating in a nebula just like that. We are the children of the dead. The universe is a recycler. It wastes nothing. The violent death of a star is the necessary condition for the birth of a planet. The Webb telescope has captured a transfer of assets. The star gives up its fortune, its heat, its heavy elements, and bequeaths them to the galaxy. It is a final act of generosity. As we move further into 2026, papers will continue to be written on the density waves and chemical compositions hidden in these images. But for us, the legacy is emotional. We have looked into the eye of God, and we have seen a storm. We have seen that the end is not a quiet fade to black, but a raucous, colorful, creative explosion. The breath does not vanish. It becomes the wind that fills the sails of the next generation of stars. It becomes us. Thanks for listening to Fun Facts Online. If you enjoyed this deep dive into the cosmos, make sure to check back for our next episode.